Hi, chemistry students. This is Mrs. Pugh, first section of Unit 2 on significant figures, measurement, scientific notation. Measurement. Something to think about is that there are two different aspects to making a measurement. One of them is the technique in which you make the measurement or how the measurement is taken. And then the second one is the method to reporting that measurement. Do you report the measurement to simply just 1 centimeter or 1.1 centimeters or 1.10 centimeters? How is that measurement reported or recorded? In other words, you have to not only be able to correctly take a measurement, and then you need to figure out a way how to tell somebody else what that measurement is. So a measurement can only be as accurate as the tool that you're using to measure. So the first question is, well, what is accuracy? Well, as you might imagine, it's how close your measurement is to the true value of whatever that amount you're measuring is. It also needs to be precise, which means it has to have two or more closely related measurements that agree with one another. So a good way of explaining this is to look at a target. So if we were to play darts with the target, and the first one right here shows, let me go ahead and circle this. This first one shows that 3 different darts were thrown at the dartboard. None of them are near each other, and none of them are near the thing that you want, which is this part right here in the middle of the bullseye. So we would say that not only was it not accurate because it wasn't close to the true value, but whoever threw these darts weren't close to each other either. So it would be like taking a measurement 4 times, and none of the 4 times were the measurements near each other, nor were they near the true value of the bullseye. Now, a second time around, you're making some throws, and it's getting closer to the bullseye, maybe these ones here, but they're not precise because the repeatability isn't very good. Now, look at a 4th one here. This one, none of them made it near the bullseye, but they are all very close to each other. This would be like somebody who was using a measurement tool, maybe a graduated cylinder, and they were reading the cylinder wrong. So every time they were consistent, but maybe they were reading from the wrong part. So that would be a not accurate, but it is precise in the sense that they are repeating it the same each way. Now, the best scenario for a measurement is when all of the measurements are close together and they are close to the true value. So this 4th bullseye shows both accuracy and precision.